Hi. So in this tutorial, whatever what we'll be doing is, so I was going through this ROS package that I created a while ago for industrial robotic arm simulation, and I noticed something. So if I increase the text of this, it's very annoying if the text is very big because it's okay. So I have this GitHub repository of ROS tutorial, but just for the sake of completion, I'll remove this and then I'll clone it again. So when I was going through this repository to run MoveIt and planning on making another tutorial, I noticed that there is something wrong as MoveIt is not working. And I was debugging it and I thought that why not make a video of how to debug a ROS package so that you can identify where the problems are coming from and how to fix them. So right now I have no idea what's wrong in it, but I know that ROS is like the move it part is not working. So whenever I try to click on plan and execute, it does not work. It plans the path, but somehow it's not working, and I have no idea why it's not working. So what I'll do in this tutorial is basically record a video of me trying to debug it, and hopefully I'll be able to debug it. So I have these two repositories. So under ROS tutorials, basically there is this GP7 robot, and I remember from my last few tutorials that under bring up I wrote this launch file, which basically brings everything back, brings everything and launches every node. Okay. So first I'll go ahead and make this workspace. And then I will open this ROS package in Visual Studio Code. I like to use Visual Studio Code over Atom or other code editor. So here's this launch file that brings up everything. And as you can see, this launch file basically brings up this, like it includes this launch file, which is control gazebo, which is under GP7 visualization package. Here, this one. So if I Yes, so it first brings up this file. So if we go and open this control_gazebo launch file, we'll see that it opens gazebo and does all the other things that you can read in the comments. And then it starts the move group server and MoveIt RVS visualization. Okay, so let's see what happens when we bring up this package. So I'll source the workspace and then I will I will start this launch file, which is basically this launch file, the, the very first which starts everything. So there are two things that I want to fix in this video during this debugging session. The first is I noticed that because I'm running virtual Ubuntu, so it's like the simulation is very slow, and one of the reason is that the meshes that I have under URDF are quite big. If I go to Catkin workspace, ROS tutorials in the description package, which is I think visualization package under meshes. So I have them in the collision and visual tag. So let's check if they are there. So if I, for example, from the Visual Studio Code, if I go to URDF and simple robot URDF or this one. So I have two URDF here. Now I don't know which ones are coming up. So what I can do is I can go back to control gazebo package, and I can see that here in the URD in the parameter server, this line is basically uploading gp7 underscore robot.urdf. So I can go to this. So there are two URDFs. So I'm using the top bottom one. So if I look at this, it's under the link parameters, it's using GP7 meshes visual and then base link. And for collision, it's using the different meshes. So this is, I will fix this, but before fixing this, we'll try to debug why the MoveIt is not working. So I can show you that MoveIt is not working by putting it in one side, move gazebo on the other side. And you can do this window snapping by holding down or pressing down the window key and then using the cursor keys. So it nicely snaps the windows on two sides or multiple sides. Okay, so as you can see that my Ubuntu is quite slow right now, and it's going to be really painful for me. But it may be possible that because it's so slow, because of this, MoveIt is not working. So that is also one possibility. But there are certain steps that one can follow to see why MoveIt part is not working in the robot or in the simulation or even in the real robot. Okay, so it's quite slow. I can't do anything with it. So I'll open another terminal, and the first thing to see whenever you start a MoveIt server, you go a little top, and here it returns this return one controllers in the list. What it means is basically, so if you have a joint trajectory controller configured with MoveIt, so follow joint trajectory controllers create an action server, and MoveIt tries to connect to that action server using its action client. But to connect to that, and if it successfully connects to that, so it returns one controllers in the list. So if, for example, if you have two different follow joint trajectory controllers, one for the robotic arm and one for gripper, then it will say return two controllers in the list. And if for example, you do not configure it properly, so it will say return zero controllers in the list, and then your MoveIt action client is not connected to any action server of the controllers. Now it's a lot of gibberish that I have just said, but a few things to check first is where is your controller, and so this is the controller action server. So action servers basically produces they have 5 different topics normally, and these are all they always end with cancel, feedback, goal, result, and status. So the MoveIt client basically connects to this server. So this is only one controller currently because I have configured for the arm. There is no gripper in it. So to check if it's working or not, what I can do is, if you have configured, there are different ways to write controllers, but one of the nice packages is ROS controllers. And if you use ROS controllers, so besides creating these follow joint trajectory action server, they also subscribe to this topic, and you can use this topic to see what's going on. So I will use this RQT joint trajectory controller plugin to see if my controller is working or not. This is the first step, I think, to see if you are going to debug anything related to MoveIt. So I'll connect this, and I think it's working, because if it was not working, it would not show me this. And because it's so slow, you can see that when I move this, it takes a while for the gazebo to execute that. Okay, so my controller is working. There are other ways to see if your controller is working. So one of them is whenever you start controllers, they are managed by a controller manager service. So if you go to ROS service list, so there are a lot of services in here. And if I scroll down, so there is this GP7 controller, list controller types, and list controllers. So I will call this service ROS service. List controllers, and then if I keep tab pressing, so it will, similar to how topics, you can do this. and it returns me this. So this was my request, and this is the response to that service when I call it. So I can do the same thing with the Python script or a C++ script, but like I'm just trying to see what's happening here. So I have two controllers. One is joint state controller and the other is ARM controller, and they both are running. And you can see that this controller is has the resources of all of these joints. It's basically controlling these joints. Joint state controllers are basically just a simple kind of a state controller, which basically tells you what is the current joint values and positions and velocity and acceleration and effort. Not accelerations, efforts. So, so this is working. So it means that my controller is working. From this line, it seems that MoveIt is also connected to my controller. So that part is also seems to be working. So what else could be wrong? Now, there is one more thing. So I hope you remember, but if you don't, so if we go to control gazebo package, so here we started a lot of things. And if I go at the bottom, we started this robot state publisher. So robot state publisher is a simple Python node which basically takes in joint states and TF from the which is transformation from the URDF, and it produces the visualization for robot how it is moving. So it's basically kind of doing the forward kinematics continuously on the robot. So one way to see if the robot state publisher is working or not is basically go to the RVS, click on add, and here you can see in the by display tab there is a robot model. So if you open this robot model, it should look exactly the same as the one in the gazebo. So to make sure it is working fully, what you can do is, you can start RQT join. I'll clear this. And I think last time I ordered this. Okay. So you can start RQT or like type fully RQT joins controllers. And if I move this robot, it should move here. So this is working, right? And why it's working, this is very important to know actually. So if you run how the nodes are connected, so if you want to see how the nodes are connected, there is a RQT graph, which is basically a graph of the different nodes and how they are connected to each other. So if you run this script, you'll see that the robot state, which basically publishes this 3D model, updates this 3D model in the URDF. It takes in the robot state and the TF static. So TF static is basically, yeah, you can think of it as transformations of your robot for each link to the next link when the robot is in joints, when the robot is in home position. And when you move any joint, so that information is published in the joint states. So it takes both of these information and then translate it into the 3D model so you can visualize that 3D model. Okay. So, and here, as you can see, like there are other things that are connected to each other. So for example, your gazebo is basically subscribing to this action server. And if I start, this one is not here, which is interesting. But like you can go ahead and look all of these things, and they can be very detailed. And if you want some nodes and topics, if you can do this and go through this graph as with what is connected to which thing. So for example, this is the RVS window, and it's subscribing to move group actions and other parts of it. Similarly, yeah. So I mean, I'm not going to go into details of this. It's something that's not related to this video, really. Okay, so controller is working. It's connected to MoveIt. our robot state publisher is working. So why, when I try to add MoveIt in it, so by the way, if you close the move group motion planning part by mistake, you can add it again by going to add and this motion planning. But if you close it and you don't want to restart everything, but I just hide it so okay. So now what I wanted to do is my if you see here, this is very slow. So if I if I select another pose, I click on plan, and then execute, it's not working. As you can see in behind the in the physical world, in the github world, it's not going there. What is it? No, it's not. So this is very frustrating as why it's not moving. It may be that like my like Ubuntu is working so slow in the virtual environment because of all these meshes that it's not it's not it's not executing really fast. So in this situation, what I would do is first I'll go to and why it's working so slow is because of these meshes. So these meshes are very slow in the URDF. So for example, if I go to collision and look at the size of this mesh, so it's 92 kilobytes. So what I'll try to do is first I'll kind of reduce this size. So think of it as, for example, if you have a image and that image is 4 kilobytes, 4K image. So it's like 4096 by 4096. So it is a lot of pixels. So it will take a lot of memory to store. And then if you reduce that image, so let's say if it's 128 by 128 within height, so it will be much smaller image, but the resolution will be smaller also and bad. So one way you can reduce the size of meshes is using a software called MeshLab. And if you do not have it installed, what you can do, you can run this command sudo apt install MeshLab. Now I already have it, so like it will not install it again. But if you don't have it, you can install it, and then on the terminal you write MeshLab, and it will start MeshLab. Now if you go to so here what we are trying to do is we are trying to reduce the meshes. So meshes or 3D CAD meshes are basically, or the STL files are basically points, and they are it's already reduced quite a lot. Oh, sorry. So I had already reduced the size for the collision meshes, but I will also reduce the size for the visual mesh. Collision meshes are used for collision checking. They should be reduced down, but I will also reduce down this visual meshes. And I think I talked about them in my second video about simulating industrial robotic arms in ROS. So if I check this, it's a quite detailed match. So if I look at the size of this, it's quite big actually. It's 39 MB. On the other hand, if I look at the corresponding collision mesh of it, base length, so it's 92 KB, so almost 1 MB. So it's like 39 times more detailed mesh. So let's reduce down this because we don't need these detailed meshes in it, even in the visual case. So a simple way to do it is basically go to render properties, and there is, I forgot actually, sorry, it's in the filters. Under filters, there is normals, and smooth. To be honest, I am not 100% sure where it is, so we'll have to find it. Mm, Remeshing. Okay, this is not. Sometimes there are so many options you can. Where is it? Okay, I think this one. Quadratic edges collapse decimation. I am not 100% sure what it means exactly, but I know that meshes are vertices, and the more the detailed meshes, the more vertices there will be. So currently it has number of faces which are vertices. I mean, number of faces are the kind of like grid. So if the grid size is very small, so it will be there will be more points, more vertices in it. But the size of that is it will be more because you need more memory to store more points. So currently it has this many faces. So you can just reduce down to, let's say, 3000. And because I'm reducing down it, so it's like it will not be that detailed. So you can see instantly, we'll calculate it. And so you see that like there are no more details on it. So currently it looks really bad. Okay. So instead of doing that, and like just to check my hypothesis or just to check my thing that it's because the matches are so big that it's slowing down all the simulation, and because of that, MoveIt is not working. What we'll do is instead of changing all the meshes here, I will go into my URDF. I will make a copy of it just for uh, I mean, it's good to have a backup always. Go to my GP7 underscore report URDF. This is the URDF that goes into the parameter server. And here I know that visual is the one that's causing problems. So I will copy this and replace it with collision like this. So I'm changing the part of visual meshes into collision meshes. Now, as you can see, this is found 7 times in the file because I have 7 links, and because it's a 6 degrees of freedom, so basically 7 links are connected by 6 joints. So 6 joints are 6 degrees of freedom. So that's why there are 7 visual tags, and you can actually look at them by going this like this. So you can see link 4, and this is the path to that. So I'm changing those path to from visual to collision. So doing that, what will happen is my simulation in the gazebo, the robot will not look that good. So because I just changed the URD, if I don't have to do the cat can make again, so I can go ahead and launch my simulation again. Wow, there are some big errors here. Okay, this is could not load model. Let's see. I think there is an error related to. I remember this error before. So I changed. Seems like I'm okay. Uh, could not load model package global meshes collision. Okay, I may have this may be the wrong path. So if I go to meshes collision, so the spelling is collision. Seems correct. Cannot locate resource GP7 meshes collision link 3USTL. Okay, it's saying this because if you remember, if you come here, so you see this .stl under visual folder is basically capital STL, and in collision it's smaller cap STL, because it's like STL are in two format. One is in alphabetic and the other is in binary. So I have to change this everywhere into smaller STL. It's not finding that. What I can do is, just to do it faster, I'll replace everything with .stl to .stl. It's also good, like, if you can do this, I think. So it makes, just to make sure that everything are properly replaced. Okay, seems like it should work now. So let's launch the file again. So now this time it found all the meshes, visual and collision, and it's loading. Now if you see that robot does not look that detailed, but it's really fast. Now I can like move around it easily. And if I snap these windows, now you can see that gazebo simulation is quite fast. Like, I mean, comparatively fast. Not still not that good. And we can plan and execute. Should execute. Why it's failing? This is still not working, but we managed to make it a little fast. Okay, so if this is still not working, as you can see, I'm trying to change the pose of the robot, let's say, to random valid, and if I try to plan it, it's not moving it in the gazebo. And I always hated this loop animation part. So okay, now what we do? So now I know that MoveIt connects to controller action server. So if you know anything about action server in ROS, and if you don't, I think we suggest you go and watch the construct video. They have really good tutorials about it. So let's see. So I will first, like, MoveIt will try to publish a topic on this. So I will echo this, and I will see if anything is being published on this topic. So I will make this always on top so that it does not go back, and click on plan and execute. Nothing is being published on this right now. Now this is a little strange. Another thing I would check is why it is not publishing to this. So it says solution found, but the controller failed during execution. This is the error from. But on the other hand, MoveIt did not publish to the code of the controller. Okay, so I just want to, like, as you can see from here, like, if I do the info, so there is move group that's connected to this, and subscriber is visible. That's something you should be well aware of now. I want to hold on, and this is the most frustrating part of doing any debugging work, even in any programming language, if you work in a software house, and to find out this kind of errors. And but it's also fun if you take it as a challenge and come up with different ideas. And so my guess is, like, one of my guesses is that MoveIt is not able to subscribe to joint states topic. So if I try to echo the joint states topic, it's not publishing anything here, which should not happen actually. Because, and if I try to publish, see, let me check the list, joint list. First topic, yes, React joint states, and S is capital here by mistake, so I will make it small. And if I try to do joint states, so there are two joint states, interestingly, and one of them is GP7. So let's see what happens in GP7. So the states are published on this topic, not the other one. So we have to remap this topic so that ROS can, like the MoveIt can use it. Okay, that's actually interesting. Okay, so basically our joint state topic is this has a namespace. On the other hand, if I go to my URDA and look around where we added the Gazebo ROS package or Gazebo ROS plugin for control part. So I'm basically snapping all those links and joins tags. Okay, so here is the Gazebo control package, and it's, as you can see, this is namespace. So every topic has namespace between them. So what I'll do, I'll just remove this for now and save it. Now, if I go ahead and bring it up again, now you can see that that MoveIt is not able to find any controllers, or even Gazebo ROS control is not able to find, because I removed the namespace from the URDF, but not from the controller part. So what I have to do is I will have to go to bring up basically takes in the control Gazebo package. So I'll go to Gazebo ROS, control Gazebo ROS package, and here you can see that this part where it says spawn controller. So it is like it has this namespace. So I will remove this part. It's passing this. And if I remove this part, then the problem is that on the top line here in the controller type, I uploaded these parameter server. On the parameter server, I uploaded this controller config. So I'll go and in the config folder, because it's in GP7, visualization config and joint controllers topic here. And here you can see that this whole YAML file has a namespace of GP7 robot. So I'll remove this. And then I'll select everything and use control and opening bracket, so it's like it to go back one indent. Actually, we don't need, like, these were from the first joint, but I'm not loading these controller. You'll see I'll show you in the launch file. I'm just loading this ARM controller and this joint state controller here. In the launch file, you'll see that there is this joint state controller and ARM controller. And yeah, so I think this will work. Now, because I removed the namespace from URDF and then from the controller, so I'll have to do the same thing for MoveIt. And I can show you that currently if I run the robot, my MoveIt will not connect to the controller. So if I just run it, so I think the controller also is not starting. Okay, I should put this always on top. This is my controller manager, ARM controller. Let's see if my controller is working first in the Gazebo. Okay, one thing to notice is that since we changed the size of these meshes, simulation is working quite fast, and it makes sense because if you have smaller images or smaller model, it's easier to load them. And yeah, so this is working. The only part it's not working is still the robot is not connected to MoveIt. So if I try to do plan and execution, let's say home pose, it will not move the robot here. If I do stand up, it should not move it because what's happening is that I changed the configuration for controller where I removed the namespaces, but I did not do it the same. I did not do the same in the MoveIt in the GP7 config MoveIt config package. So if I go here, the controller package, you can see that it's basically MoveIt thinks that the action server it has to connect to is basically this. But in actual, we removed this part. So here we have to remove this part. And probably / also. Okay. So now if I go ahead, also I think there still remains one thing, but let me check. Let me see. I'll start the launch file again. And you'll notice that this time everything connects. As you can see, there is it returned one controller in the list. And if I go to models, GP7 robot, move to it, snap it. And if I move the robot to stand up pose, to plan and execute, so it now works. Perfect. So this is like to be honest, debugging part of the job in robotics is always going to be difficult, but you should not always you should not take no for an answer and keep looking as where the problem is coming from. Try to see different things, and I broke the robot now, but yeah. There is one more thing that I wanted to mention in this tutorial beside debugging, and that is I wanted to show how you can use MoveIt from command line interface. And I find it very useful if you are debugging something and if you're just checking if your robot is properly configured with the robot with the with MoveIt. So first of all, always make a good habit of using GitHub and Git. So because I make these changes, and so I will use GitHub Git to commit these changes with working. Okay, I'll push it later. Okay, so if I go back and I run this launch file again, this bring up launch file. Now, let's say you are working and you just want to see if your robot is properly configured with the ROS, with the MoveIt. So there, and you want to do it with terminal instead of writing any Python script or instead of using this visualization. So there is a very well written Python command line interface that you can use for MoveIt commander. So if you run ROS run MoveIt, MoveIt commander, and then MoveIt command _ commander _ cmd line.py. And before doing that, I would suggest that you source your terminal from that. So otherwise it will show you these errors, but it's not, I'll do it again. just in case. I'll source in my terminal, and then run this. So now you'll notice that it will not give me that retrieving file error. See? Yeah. Okay. So this is this like as it says, waiting for commands. Type help to get a list of known commands. So you can just type help, and it prints these help commands here. And I know a few of them, and I sometimes use it if for example, if I'm in a hurry and I just want to see a few things in MoveIt instead. So for example, if you want to use a move group, so I know that the name of this robotic arm move group is arm, so I can write use arm, and it will connect to that. Okay. Then I can say, for example, go rand, which is basically go to random position. So I will make this a little smaller so it's easier to see. So, and we'll make this on top. It's already on top, and then move the robot. Okay. So if I type in terminal go rand after using the arm, so you can see that here in blue it prints arm. If I do go rand, so it will go to random pose. It's kind of similar functionality where if you click here on the goal state and select goal random value, and then click on plan and execute, so it kind of does that. Similarly, you can type go to home because we have a home post saved. So if I do go home, so it goes to home. Similarly, we can do go stand up because stand up is a predefined pose in MoveIt config that we defined it. It's not predefined in the MoveIt, it's predefined in our MoveIt config package. Okay. Then we can also say go, for example, go up. Okay, so first we'll go home back because this is kind of this pose, the stand up pose is like, I think it's not going to work. Go down 0.1. 0.01. So it will go down 1 centimeter at the end pose, I think. It did not actually. I have been trying to do this, but like, let's see. Forward 0.01. So this is the kind of like it's not working right now, but I have to read up on that as how does it work. But this is the kind of experimentation that I would suggest you guys do because you're running simulations. So it's not like you're not going to break anything. You can just randomly run other commands and see what happens. For example, current returns you the current joint values. So these are the joint angles of the current pose. And this is the current pose with respect to world frame. So it's the current pose of link frame with respect to world frame. So, and this is the link sets RPY value because it's in quaternion hero orientation. So they also provide it in RPY, which is role ratio. What else is there? Let's see. Right. There are quite a few things actually. Display joint names. If I just type joints, what happens? These are the joint names in the group, which is correct. EEF. EEF. This is the end effector link in the group. This is the command I was trying to run, but it did not work. So it says go dir and dix, and it says plan and execute a motion in direction up and down, left, right, go forward, backward, forward for the distance dx. So I have to type dir and then dix, I think. I'll add a ground plane to the planning scene. So let's just save let's just run this command first ground. See what happens. So you see in the RVs that creates a ground. So now if I like adding a ground basically like this means that if I try to go lower than this ground, it will be hitting that ground, and based on that it will not plan. It will fail the planning because of the collision. I'm actually surprised that it's not working for Go. I was really hoping that it would work. Go home. Go down 0.1. I'll try all 6 directions. Go forward 0.001. I don't think it's seems to be good. I don't think it's working. But oh, actually it did work. See, it was moving. So if I do go down in the minus direction, so it went back. That's interesting. Let's say go backward 0.01. So as you can see, forward and backward is basically this axis along this axis. So if I try go up 0.01, I don't think that's going to work. But you get the idea, is what I'm saying. Like you can run these commands on your own and see what happens. And then if you want to exit it, so you can just do exit and it will nicely exit. So that's all for today. I hope you like this video. Subscribe to my channel for more videos. Bye bye.